Here you go, type 3, story. A scenario, right? A scenario where you're provided with 2 points, you have to find a third point. This is on page 71, by the way. You're provided with 2 points. You have to find the third one. Using symmetry, right? So remember the axis of symmetry, I just talked about it a little while ago, and I also talked about it before. It's coming back here. It's going to help you out. Best way to solve this type is to sketch it first, right? Sketch it first. I would strongly suggest you sketch the scenario. What's happening? Remember, the third point will be across the starting point. The third point will be across the starting point. And I'm kind of gonna, spoiler alert, if you do a cubic, which is something with a power of 3, you need 4 points. You need one more point than what the degree is, right? So if it's a degree of 2, you need 3 points. And if you forget, just try it. Quadratic regression. If you just give it 2 points, it's gonna say, can't do it. Give me more info, right? So if you forget, that's what it is. So I'm going to break this down into 2 scenarios, guys. This is the most common one, where you are given a starting point and a vertex, and you have to find a third one. And then the second scenario is where you get the start and the end points, and you're going to have to figure out the vertex from those 2, right? So that's how I break this down, and this is just to help you understand what we're doing later, okay? Let me just have these notes here. So on the ground or off the ground. So that's, remember, this side is starting on the ground, this side is starting off the ground. So let's have a scenario here. A ball is kicked and reaches a maximum height of 17 feet after 1.25 seconds. So right here, you should recognize that that's the vertex. You just have to put it together in the right order, okay? Some students will say, oh, 17, 1.25. It's like, no, read the question. Time is always on the x-axis. Okay? So what that means is that after 1.25 seconds, you reach a maximum height, right? The height is second of 17 feet. So that's what's given there. And the starting point is implied, right? You're kicking the ball right on the ground while it's on the ground. So this is 0, 0. That is a powerful point, guys. You might think of it as, really 0, 0? Yeah, it's very important to have that, right? Because then quadratic regression knows, okay, this is starting right here. And so your third point is this one. So this is the first, second, which is also the vertex, and this is our third point right here. I'm going to put it down underneath. That's the third. So I want you to remember this. This is a bit of a pattern. Where do you start? You start here. Okay? By definition, right, both arms they'll be at the same height. So we're just going to go across, and we know that this point will be at a 0 as well. Okay? And it's this one here that is different. So axis of symmetry, let's just make a dashed line right here. Okay, it takes 1.25 seconds to get to the middle. It'll take another 1.25 seconds to get to the other side, on the opposite side of the starting point. So you essentially, when you have this scenario, you can just take this and multiply that by 2. Double it. Like if this took 2.5 seconds, it'll take another 2.5 seconds, right? So it'll be 5 in total. So this is 2.5 seconds right now. And then I want you to try to organize your points in a small little table. So time and height. So we have 0, 0, 1.25, 17, that's the maximum height, and after 2.5 seconds, you'll be back at the same height than where you started. That's the key there. So I'm going to highlight the third point because I used orange, right? Earlier, I used orange to highlight the third point here. So I'll do the same here. This is my third point. That's the one I determined on the graph, and then I also put it on my chart, T-chart. So this is on the ground. What if it's off the ground? Right? An object is thrown from a height of 8 meters and reaches a maximum height of 13 meters at a distance of 3.5 meters. This, I hope you understand, that is your vertex. Right? That is your vertex. Let me see if I can zoom in a little bit more. There, not much, but so the vertex is a height of 13 at a distance of 3.5, and that you can clearly tell that distance is your x and height is your y. Okay, so we're going to go 3.5, 13, that's given. It says that the object is thrown from a height of 8 meters. Right? I'm going to say this, I'm going to circle that. That's initial height. Initial height, which is also known as our y-intercept, correct? You remember that? So this point is 0, 8. Everything that's in pencil is given, right? We don't need to really do much about that. We have our axis of symmetry still going down the vertex, or right across the vertex. And here perhaps I will use a highlighter, a different color that I haven't used yet. But I want you to focus not on, a lot of students focus on the x-intercept. Oh, x-intercept, because this one, remember, that was the x-intercept, so we found that. But here, try to focus on, right, the same height. So if you're here, you're gonna come back to that height over here. Okay, that's what I want you to focus on. And maybe I'll use the same highlighter for my very first graph. I'm just gonna say under the x-axis, I'm just gonna say, hey, we focused on, right, the point that's across the one I'm at. Okay, so what does that mean? It means that the third point, if I start at 8, I'm going to come back to 8. I'm going to come back to 8. And watch this. It took 3.5 seconds to, sorry, not seconds, meters, because we're talking distance. It took 3.5 meters to get to here. It will take another 3.5 to get to the other side. 3.5 is 7, right? 2 3.5s. That's what you have there. So I'm going to take this. I'm going to go times 2, because quite frankly, is always going to be the case. And then it's 7 there. And then organize your thoughts here. So we have distance and height, don't mix them up. So 0, 8, 3.5, 13, and then 7, 8. See, you're back. You should see that you're back on the same height than what you started, right? And I'm just going to highlight my third point, saying, hey, that is what I needed to kind of complete the puzzle. Now I can do a regression. I'm not going to show you how to do a regression because you know how to do it at this point, hopefully. Okay. So this is when you have the vertex given. We'll do this a similar scenario when the vertex is not given. Okay. Or at least the x value of the vertex is not given. So I'm going to travel down to that bottom page, bottom half here you go, and I'm going to go a little faster on this one. So you're on the ground, and there's a max height of 40 feet. I'm just going to highlight that, or that's the vertex. That is part of the vertex. So we know that we will reach that height of 40 feet, but we don't know how long it will, like at what time that happens. Okay? Because what it says is it lands and remains airborne. It says here remains airborne for 8 seconds. Okay? This is the second x-intercept that is given to you. We know that at way over here when it lands on the ground, right, that this is 8-0. At 8 seconds, you reach a height of 0. We are also told, right, an object is thrown upwards. We know that this is 0-0 right here. 0-0 within the context. And let's look at our axis of symmetry again. If it takes 8 seconds from here to here, then halfway would be divided by half, right? Like it would take 4 seconds to get you to the halfway mark. So I'm going to take this, I'm going to bring an arrow. So you just have to be very careful. What is this question telling me? You're going to divide that by 2 and say that after 4 seconds, you reach that maximum height. And I'm going to use orange again. So your third point is your vertex in this case. So you have time and height. Sorry, I need another cup of coffee here. Time and height 0-0, 440, 8-0, and this in this case, that is the one I needed to complete, right, to be able to perform the regression. Last but not least, distance and height. It says a skier goes down a 30-foot ramp. You're off the ground. This question is giving it away already. You're going down a 30-foot ramp. That is the y-intercept. Right, so that's your starting point. That's 0-30. The lowest height is 12 feet. That's part of vertex. So we have this point right here. I don't know where I'm going to label. I think I'm going to label it right here. We don't know the x value, but we know that it's 12 feet. Right there. And it says reaches the initial height at a distance of 50 feet. So the initial height would be, this is our axis of symmetry. The initial height, we're kind of thinking of it this way. Right? There's a point across here, which is the initial height. It will be 30 again. That happens after 50 feet of skiing, right? So 50 feet horizontally gets us back to the initial height. So this is a bit of a trickier problem because it's curving up, right? It's pointing up. However, it still applies that we would just take the 50 and just divide it in half to get that point right there. So that would be 25. And you may have to look at this in more detail later on, right? Right now I'm kind of just glancing over it just to give you a bit of an idea of how we're going to work these questions. So this would be distance and height. We got 0, 30, 25, 12, 50, 30. By the way, quadreg doesn't care in which order you give the points, as long as the points are correct. I will tell you one thing: if you get an error after entering these, like you try to do your quadratic regression and it says domain or something, chances are that one of them you flipped. It's the other way. Someone didn't read the vertex right and you went 44 instead of 440. Something isn't right. Go back and check your points. Okay, do they make sense? Sometimes when you do a just graph and you see your points, one of them is way off. That's also an indicator that you did something wrong. Okay, let's do an example. Page 72. And I will tell you this one has a curveball in it right away. You might think you should start easy and then go a little harder as you go by, as time goes by. And I thought, no, this time I'm going to go straight into the curveball. That's a baseball term, by the way, even though I don't play baseball. Curveball is when it's not straightforward, right? It's trickier to get it. Roger would like to recycle his beverage container. He throws his container up from a height of 1.75 meters and estimates that it reaches a maximum height of 2.8 meters after this many seconds. I think you should probably say, yeah, that right there is my vertex. I don't know about the rest right now, but it's a maximum height reached, highest point, hint, hint, vertex. The container lands on the rim of the recycling bin. So it doesn't fall into the bin. It lands on the bin. I'm picturing these blue recycling bins that have like this small hole in the top, but they have a big rim that I can land on. So basically, it's a fail, right? Don't quit your day job, they would say. The bin is this tall, and that's the curveball right there, just giving you a heads up already. But it's still going to be part of our story, okay? Still going to be part of our story. So let's sketch this first. I just want space. So let's try to envision what's happening here. Sketch first. I'm going to say that. Sketch first. I would strongly suggest you sketch first. And it's a sketch. It's not a graph. I'm not gonna take marks off for a bad scale or anything like that. I don't, right? I just know that time will go here, height will go there. And we're told that this container is not thrown right on the ground, it's off the ground, right? From a height of 1.75 meters. So that's off the ground. And these questions can be done without the page I just did before, by the way. You can just read and understand and try to figure out. So we're somewhere here. This container is being thrown up and lands. Where is it going to land? At a height of 0.65, right? So that would be below where you started, somewhere here. Lands on rim. And what's our starting point? Let's put some points in here. Our starting point is that at time 0, it was at 1.75 meters. That's point number 1. We know our vertex. Our vertex is 0.75 seconds. 0.75 seconds, 2.8 meters. And here's the curveball. I kind of wanted you to focus your attention on this, but don't focus on this. Remember, we always talked about find the point that's right across this one, right? So I'm going to take my pink highlighter and just say, this is a very small sketch. I apologize for that. I'm going to zoom into the sketch so you can see it a little better. But let's put a red dot right there, right? That's our third point. We're going to focus on that. We know that this point has a height of 1.75, right? Because you are 1.75, you throw it up, it's gonna come back to that height. Even if it had to touch the ground at some point, it would come back to 1.75. 1.75. And this part is where your axis of symmetry comes in handy, right? If it takes 0.75 seconds to get to the highest point, it will take another 0.75 to get to the same height that you started off with. So times 2, we get 1.5. Almost got it right. 1.5. And the question says, determine the quadratic equation that models this path. And that's what we're on the way of doing that. So I'm going to say time and height. At time 0, we're at 1.75. After 0.75 seconds, we reach a maximum height of 2.8. And at 1.5, we're back to 1.75. I'm going to put this into L1. I'm going to put this into L2. Stat, calc, quadreg. Oops, I'm off the charts here. In a bad way. Let's do that. Let's enter our, just to slow down things a little bit here. Go to the top, hit clear, enter, and hit clear, enter again. So 0, 0.75, 1.5. There's no multiplying, right? Remember the profit question? You would go L, like the first column times the second column. This one doesn't have that, doesn't have the third column, okay? So that's why the story is also unique. And so 1.75. I can't type and talk at the same time, right? Like I need to stop. Not as talented as you. So now we go ahead and do the regression. I'm going to check my home screen. If I just did the regression, copy, paste, run it again. There it is. This curve models, it's a negative, don't forget the negative, 1.87x squared plus 2.8x plus 1.75. It shouldn't surprise you. The 1.75 should not surprise you. That is exactly what we expected. Okay, so now you have the equation. I can ask a whole bunch of questions. So here we go. How long does it take for the beverage container to reach the rim of the recycling can? Because you're probably wondering, like, what about this point? Like, what about that one? It was a curveball. You didn't need to know this point to find the quadratic equation. You just needed to focus on, hey, I have 2, I can find a third. That's how the parabola works, okay? So this one was just there to kind of distract you a little bit. I apologize, but I warned you, right? So now it says, how long does it take for the beverage container to reach the rim of the recycling can? Reach the rim, right? What do we know about it? The height is 0.65 meters. Right? The question is saying, hey, when does that happen? When does it reach that height? And so we will use y2 is equal to 0.65 and then just find the intersection. You're probably wondering why my writing is so weird, right? Why do you do print sometimes and handwriting other times? I grew up, and I told you the story, right? I grew up in South America. I had to do handwriting, everything handwriting. Then I moved to Canada and my teachers wanted me to print. So I'm all mixed up, but for life, I'm scarred for life. I can't fix that. So we go, y2 is 0.65. Did I graph this already? I didn't. I don't think so. I'm going to try it, see what happens. It's a terrible graph, right? So I'm going to try Zoom 9. Not really good yet. My X-Men is negative 0.15. I'm actually okay with that. Like you can go -1. I always go -5, but when the numbers are small, maybe don't make it too big. So I'm actually gonna go negative 0.5 maybe. X max, I'm gonna go 3. Y min, I'm gonna go negative 0.5. And Y max, I need to be at 3 for sure. So read your situation, right? So this is where it's launched, and it hits the rim right there. So I'm going to find that intersection. And that happens. I put down the point, right? It reaches, come on. It reaches the rim. After 1.82 seconds. How long does a container remain below 2.5 meters? Let's see how that works. We've done these types of questions before. I think what you should know for sure is, well, let's focus in on that height. What happens there? Second, trace, intersect. Let's go ahead and see what that looks like. Y2 is 2.5. Sorry, 2.5, not 2.55. Okay, it does within our domain and range, right? We start at time 0, right? We start at time 0. Within our domain and range, it reaches that height twice. The question is asking, how long does it stay below that height? So we don't want the tip of the valley, of the hill, right? We don't want that. We just want what's below it. So let's, I will do this. I will sketch it for you again. It's important to see how this works, okay? It lands somewhere on the rim. This is our 2.5 line. So we're going to figure this out. We're going to find time 1, and we're going to find time 2. So let's go ahead and do that. You beat me to it. I'm going to start with time 2 because it's 4 decimals, right? Because we're not done just by finding the point. We're going to use these points and find delta t, right? So we're going to go 1.1509 for this instance here. If you want full marks, make sure you do that, right? Because it's usually a 2-mark question. And this is 0.3491. So there you have both instances. And here we go. And somewhere in your study sheet, you should probably have, right, delta t is 1.1509 minus 0.3491. This gives the top. This difference will give the top. So let's figure that out. Delta time and I'm going to use my highlighter to say that this would, if you subtract, you get what's in between those two values, guys. If you subtract, you get what's in between those two values, but you don't want what happened in between. You want actually what is outside of that. So to get below, this is seconds. Oh, I have to hurry a little bit. Above right? Seconds above 2.5 meters. And so to get below, how are we going to tackle this? Time below, I'm going to take the total flying time of this container, which I already know because it stops when it hits the rim, right? So in this instance, this is the total flying time. 1.82 seconds minus 0.8018. So I have this on my calculator. I'm just going to go minus 1.82, just like that, even though I know it's a positive value, right? So 1.02 seconds. This is what I'm after. This I'm going to circle. And I'm going to use a different highlighter, right? This is the time that actually where the container spends below empty. I'm gonna we'll finish this question, okay? I want you to be able to see a full one with graph and all. So let's do the domain and range first. My domain starts at time 0 and it ends when the time ends when it lands on the top of the rim, which for us is 1.82 seconds, right? Our range, what's the lowest height this reaches? The lowest height is 0.65 meters, and the highest in this case will be the vertex, right? It comes from the vertex, which is, we're told, 2.8 meters. I will actually give you more details, right? This is the rim, and this is the max height. That way you know where I got those numbers from. And let's quickly graph this. I need to go all the way out to at least 2. So I'm going to go half, 1, 1.5, 2. That's good enough. This is time in seconds. This is height in what? Meters, right? Not yards, not feet. You got to make sure you get that right. And I need to go all the way up to, my highest is 2.8. So I'm going to go half, 1, 1.5, 2, 2.5, 3. You don't need a grid, but in this case I provided you one, right? So we start at 1.75, which is right here, 0, 1.75. At 1.82, we're at 0.65. This would be 0.75. 65 is right about there. Our maximum height is reached at 0.75 seconds right here, all the way to 2.8. This would be 2.75, so 2.8 is right there. And if you want to introduce the third point, which was at 1.5, you're back to where you started, right? If you now you have 4 points, even better. So you go up, vertex, drops, and it has to stop there. Because if you don't stop there, your domain and range is going to be off, right? You only see graph for these parameters here. Okay, tell yourself, don't hit the ground. We're not hitting the ground. Okay. If you see anything that isn't type, I want you to focus on type 3 today. And maybe some of you might need to review the revenue questions. But if you see something that isn't like type 3, ignore it for now. And the homework questions, I'm going to post these. Remember, my keys are detailed, like I don't just give you the answer. So even if you're stuck, look at the key and try to get unstuck that way. Okay? Thank you guys. You did great. You survived. Glad it's over, right?